Okay, so today I'm going to talk about the Huygen principle. Before moving ahead to discuss it, let me discuss the very important concept here. What is wavefront? So what is wavefront? What is wavefront? Okay. Actually, it is a locus of point in a scene. It is a locus of a point in same medium. A point. It is a locus of a point in a medium which has the vibrational has the vibrational uh, take the locus of all points in a plane which is the same vibrational phase. It is a locus of point in a medium which is the same vibrational phase. So what does it mean? For example, let's consider an example of this. Wait. So yeah, we can take it. For example, this is basically a body. Okay, let's consider it as a body. Just different rays are given out. They beam of a light. Rays are given out. Here, different rays are given out in certain way. Okay, so for a while, consider it is moving. This is point A, and it is moved to this point through existence. This is basically a existence in time t. Yeah, we will discuss the formula as well. Existence in time t. Whose thing was for as well. This is E. Right, it moves here. This is existence in time t. Same goes for here as well. Like T in time t. Just not T. This is B. So when you want to join this all the point, you will see spherical. So this is something created like this. This is created when you join all the points. We know that the y equals to a sine and a sine. Here we will sine that sine omega x plus k. This is basically a formula of a. So here you can see here the that's neglected. Let's just write this formula. For example, let's so this is basically a motion of a particle and this is motion of a wave. This is the formula for motion of a wave. This is the motion of a particle. So we know that the y don't write y is equal to a1. For example, this is a1 and omega 1 x into kb. Same goes for it as well. Omega x1 plus k2. Okay. A1 then A2 equals to omega 2 not equals to but omega 2 k omega 2 kx plus k t. इस तरह से we write different phases and you will observe that the phase of each wavefront is same. It will make the same spherical. And if you go here as well, here we will draw another circle, something like this. So this is a concentric circle, right? Only the phase of this from here to here is same. Phase from here to here is different if we compare these two phases, right? So let's just remove it. Okay. Yeah. We're gonna discuss the next concept here, which is type of wavefront. So types of wavefront. Types. Types of wavefront. I want to discuss about the types of wavefront. The first is spherical wavefront. Now, what is spherical wavefront? For example, this is a source. The rays are coming out. Something like this, which is perpendicular to the wavefront. This is something coming out. Okay. So this is basically a wavefront. So spherical wavefront when the primary source of particle is from the point. Primary source of light is or primary source is point or the center point, right? So this is spherical. If we talk about the next one, which is for example draw two boxes, something like this. One box, two box. These are the one, two. This is basically the light source. Is from the infinity or very left or very large distance. The plane that we get phase is a plane phase. This is basically a plane phase. Plane phase. Plane phase. This is the first type, which is the spherical now. This is first. I'm writing their name here too. So this is second. Spherical wavefront. This is source from infinity. Source from infinity, and this is plane wavefront. This is plane wavefront. This is plane source from infinity. Spherical wavefront. This is plane wavefront. Wait. This is spherical wavefront, and this is source from infinity. This is plane wavefront. So let's discuss about the linear wavefront now. Let's see this linear wavefront. Linear wavefront. Now, what is linear wavefront? Now, linear wavefront is the source is from the linear source is linear, right? For example, this is a cube. The wavefront that we get through it is actually cylindrical wavefront, right? This is basically a linear source. This is something like this: the one source, the other source, the third source. Though the wavefront we get through it is the linear wavefront, or a cylindrical wavefront we get through it, and this is linear source from the linear source, not linear wavefront, but from the, let's just neglect it. It's neglect it for a wide and linear linear source, right? So these are the types of wavefronts. Now let's discuss the next concept here, which is okay. With slowly, I'm just omitting all the pictures which are here on the board. That's unintentional, right? So, for example, now let's discuss the spherical node. Not spherical node, but spherical wavefront. This is basically our center point. 1, 2, 3, 4, 5. Let's see how willing how many seconds you want to make. Let's fill it with color. Let's take a star. We have filled it with the color. Right. So each, this is, what is it? It's basically a wavefront that is formed by the primary point, your primary source, or a primary source of wavefront that we have gotten is this wavefront. Now each has a point. This point is actually a disturbance point, which creates its own secondary point, which creates its own wavefront, which is known as wavelet. So what interpretation that we can make that secondary wavefront is scattered everywhere. So primary wavefront, we have a primary wavefront, right? And it has point. This point creates its own wavefront. Primary wavefronts have point. Primary wavefront have point, and the point creates its own secondary wavefront known as wavelet. So this primary secondary points which are located in the primary wavefront create its own wavefront known as secondary wavelet. You need to keep in your mind the comment engine, right? Secondary wavelets scattered everywhere with the speed of wave. The key is the source of secondary disturbance, and this is a secondary source and emit their own wavelet. So it will create its own secondary wavelet. This is the point which is located in the primary wavefront, creates its own wavelet, the secondary wavelet. So this is primary wavefront, right? So if we draw two tangent points, something like this, one tangent, two tangent, three tangent, an arc, 4, 5, and 6. We know that the speed. This is the distance x. For example, let's take a small left that is visible. This is distance x. This is the distance x in a time t. Same goes for it. Distance x in time t. The same goes for it. Distance x in a time t. So the distance between the wavefront and this arc is equal in equal diameter. So when you want to join this all, like that, join this all, you will get a new wavefront. So this actually this creates a new wavefront. The common tangent on secondary wavelets. This is a common tangent on secondary wavelets in forward direction give new wavefront. As you can see, this is a new wavefront that has given here a new wavefront. So this is known as yeah. So this is basically the concept of wavefront. So let's discuss the last and then we will finalize our video. In that last, this is a primary source. These are the I'm going to select 1, 2, 3, 4, 5, right? So this is basically it has a disturbance here. The primary wavefront has a point which creates its own wavelet. So this is the secondary wavelet, and then secondary wavelet has arc or common tangent drawn like this. So this is x and time t, so it creates a new wavefront, something like this. Now I'm writing filling each and every space here. So this is basically a primary wavefront. Primary wavefront. Wavefront. And okay, let's just write it that of it. These are primary. This is primary source, primary source, primary source, primary source, and this is basically a wavefront. Wavefront. This is basically a secondary disturbance. This point is basically a secondary disturbance. Secondary disturbance. Secondary disturbance which creates its own wavelets. Secondary disturbance. Curved band which creates its own